Okay, in this video we'll be doing assignment 7 from my Calc CD class, which covers multivariable calculus. Here we are going to be doing a triple integral over a box, basically, in space. So we're going to have constant bounds. Let's see what the problem looks like. We have f of xyz is x times e to the y minus 2z. X goes from 0 to 2, y goes from 0 to 1, and z goes from 0 to 1. All right, I think I'm good. I'm going to write it down. I'm going to color code it. When I can, I like to go dz, dy, dx. So integrate with respect to z, then with respect to y, then with respect to x. It's just my preferred order of doing these things, so it's pretty straightforward in this case. 0 to 2, 0 to 1, 0 to 1, x e to the y minus 2z, dz, dy, dx. Okay. So if you look at this, you can actually write this integrand, right, f of xyz, as a function of x times a function of y times a function of z. We're going to use our favorite property and just turn this into a product of 3 integrals, one with respect to x, then y, then z. So I'm just going to break it up. The reason we can do this, by the way, is that e to the y minus 2z is e to the y times e to the negative 2z. So that's why we're allowed to do this. So we will get these 3 integrals, 0 to 2 of x, 0 to 1 of e to the y, and then 0 to 1 of e to the negative 2z. So it comes down to, can you find the antiderivatives? But of course you can. So you'll get 1/2 x squared, and that's going to go from 0 to 2. You will get e to the y, and that will go from 0 to 1. And then you will get negative 1/2 e to the negative 2z, which is going to go from 0 to 1. Okay, and now we just fundamental theorem this. So you get 1/2 of 4 minus 0, so half of 4 is 2. And you get e to the first minus e to the 0. Don't forget, e to the 0 is not 0, it's 1. So this will be e minus 1. And then we'll have negative 1/2 e to the negative 2 minus 1. I guess you can do 2 times negative 1/2 to get just negative. But then I'm going to leave everything else kind of as is. I'm only going to do one more in this because then they kind of like switch to a slightly different thing. So I'm going to do the next problem, and then in another video, I'll come back and do a couple more. So number 4, f of xyz is x over the quantity y plus z squared. This is interesting because that is a function of x times another function of y and z. So I'm going to be able to split this using kind of my favorite property, but I'll split it into a function of x times a double integral with respect to y and z. That's the plan. All right. So when you have it given this way, it's always x and then y, then z. You can like count on that because otherwise what would we do without that convention? Everything is constant bound, so I'm going to go dz, dy, dx. So I have 0 to 2, 2 to 4, negative 1 to 1. Our integrand dz, dy, dx. Given a choice, I will always do that. Because, like I said, it's a function of x times this other function of y and z, I'm going to split this into a product of 2 integrals, one with respect to just x, and then the other is going to be dy, dz. dz, dx. So dz, dy. Man, I'm struggling right now, but I'm going to press onward. So that's going to look like our integral from 0 to 2 of x, and then 2 to 4, negative 1 to 1, quantity y plus z to the negative second, dz, dy. Okay. We can just do the first integral. So that'll be 1/2 x squared from 0 to 2. Now we have to actually integrate here with respect to z, right? We have y plus z to the negative second dz. That's just reverse the power rule. So it'll be negative quantity y plus z to the negative first from z equals negative 1 to z equals positive 1. So 2 to 4, quantity negative quantity y plus z to the negative first. Remember, reversing the power rule. Z is negative 1 to z is positive 1. In the next step, 1/2 x squared. So it's 1/2 of 4 minus 0, which is just 2. And then we have to plug in. So we still have the integral from 2 to 4. We have to plug in z equals 1 and then plug in z equals negative 1. So that'll give us negative quantity y plus 1 to the negative first minus negative, which is plus, and then y minus 1 to the negative first dy. So these are both going to be natural logs because it's like 1 over u. So we'll have 2, and then we'll get negative natural log absolute value of y plus 1, and then plus natural log absolute value of y minus 1. Okay, and then this will be from 2 to 4, There's no other variables at this point, so you don't have to say like y is equal to. All right, so if we plug in 4 and we plug in 2, I'm just going to go for it. So plugging in 4 gives us negative natural log of 5 plus natural log of 3, and then minus the quantity, we're going to plug in 2. So minus the quantity, negative natural log of 3 plus natural log of 1. Natural log of 1 is 0, so that goes away. So we actually end up with, if you combine like terms, 2 quantity negative natural log of 5 plus 2 natural log of 3, which is just 2. And then you have the natural log of 9 over 5 because the coefficient 2 becomes an exponent, so that becomes natural log of 3 squared, natural log of 9. And then you really have natural log of 9 minus natural log of 5, and subtraction becomes division. All right, I'm going to stop this video here and come back in the next one and I think finish this part of the problem set. All right, I hope this was helpful and good luck.